According to the 2020 National Electrical Code, Section 424.36, appliance disconnect, paragraph E, clearance from cooking equipment states where the disconnect is installed on or adjacent to the cooking equipment, a minimum clearance of 30 inches from the edge of the cooking surface to the vertical center line of the disconnect shall be maintained. This code section requires a 30-inch clearance between the edge of the cooking surface such as a gas stove and the vertical center line of the electrical panel. If the panel board is located 1 foot or 12 inches to the side of the gas stove, it meets the 30-inch clearance requirement. However, local codes or building regulations may have additional requirements for clearance between electrical panels and gas stoves. It is recommended to check with your local building department for any specific restrictions. For safety reasons, it is always advisable to maintain a reasonable distance between electrical equipment and sources of heat to minimize the risk of electrical fires or damage to the equipment. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It's updated every 3 years to incorporate new technologies and best practices. Understanding and adhering to the NEC is crucial for electricians, contractors, and homeowners to ensure electrical safety and prevent hazards. When dealing with electrical installations near appliances, several factors must be considered. Firstly, the NEC defines specific clearances to prevent overheating, arcing, and other potential issues. Secondly, these clearances vary depending on the type of appliance, the voltage of the electrical system, and the materials used in the construction. Thirdly, local codes and regulations may impose additional requirements beyond those outlined in the NEC. It is important to consult with local building officials to ensure compliance with all applicable rules. In the case of an electrical panel near a gas stove, the primary concern is the potential for heat and moisture to affect the electrical components. The NEC addresses this in Section 424.36c, which mandates a 30-inch clearance from the edge of the cooking surface to the vertical center line of the disconnect. This requirement aims to prevent the disconnect from being exposed to excessive heat, which could damage the insulation and lead to short circuits or other electrical problems. Furthermore, the NEC contains general provisions that address the protection of electrical equipment from physical damage. Section 110.11, for example, requires that electrical equipment be installed in a neat and workmanlike manner and that it be protected from environmental factors such as moisture, dust, and physical damage. These requirements are particularly important in areas where there is a potential for exposure to water or other liquids such as kitchens and bathrooms. In addition to clearance requirements, the NEC also addresses the grounding and bonding of electrical systems. Grounding is the process of connecting electrical equipment to the earth, which helps to prevent electric shock and reduce the risk of electrical fires. Bonding is the process of connecting different metal parts of an electrical system together, which helps to create a low impedance path for fault current. Proper grounding and bonding are essential for ensuring the safety and reliability of electrical systems. The NEC specifies detailed requirements for grounding and bonding, including the size and type of conductors that must be used, the methods for connecting equipment to the grounding system, and the requirements for testing and verifying the effectiveness of the grounding system. These requirements are designed to minimize the risk of electric shock and prevent electrical fires. Another important aspect of electrical safety is the use of overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to interrupt the flow of electricity in the event of a fault, such as a short circuit or overload. The NEC specifies the types and sizes of overcurrent protection devices that must be used in different electrical systems. It also requires that overcurrent protection devices be properly installed and maintained to ensure that they function correctly. In addition to these specific requirements, the NEC also contains general provisions that address the safe installation and use of electrical equipment. These provisions cover a wide range of topics, including the use of approved materials, the proper wiring of electrical circuits, and the safe operation of electrical equipment. It is important for electricians, contractors, and homeowners to be familiar with these general provisions and to follow them carefully to ensure electrical safety. When working with electrical systems, It is always important to take precautions to protect yourself from electric shock. Firstly, always turn off the power to the circuit before working on any electrical equipment. Secondly, use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. Thirdly, never work on electrical systems when you are wet or standing in water. By following these simple precautions, you can greatly reduce the risk of electric shock. In addition to the NEC, there are other standards and guidelines that address electrical safety. The National Fire Protection Association, or NFPA, publishes a wide range of codes and standards related to fire safety, including NFPA 70E, which addresses electrical safety in the workplace. The Occupational Safety and Health Administration, or OSHA, also has regulations that address electrical safety in the workplace. These regulations require employers to provide employees with training and equipment to protect them from electrical hazards. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are typically conducted by local building officials or certified electrical inspectors. During an electrical inspection, the inspector will examine the electrical system to ensure that it complies with the NEC and other applicable codes and regulations. If the inspector finds any violations, they will issue a notice of violation and require that the violations be corrected. The NEC is a complex and comprehensive document that contains a vast amount of information about electrical safety. It is important for electricians, contractors, and homeowners to be familiar with the NEC and to follow it carefully to ensure electrical safety. If you have any questions about the NEC or electrical safety, it is always best to consult with a qualified electrician or electrical inspector. The purpose of the National Electrical Code is to safeguard persons and property from hazards arising from the use of electricity. The NEC is not intended as a design specification or an instruction manual for untrained persons. It is a set of minimum requirements that must be followed to ensure electrical safety. The NEC is updated every 3 years to incorporate new technologies and best practices. The NEC is adopted by most states and local jurisdictions in the United States. It is also used as a model code in other countries around the world. The NEC is developed by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops codes and standards related to fire safety. The NEC is developed by a committee of experts from various fields, including electrical engineering, electrical contracting, and electrical inspection. The NEC committee meets regularly to consider proposed changes to the NEC. The proposed changes are then published for public comment. The NEC committee reviews the public comments and makes revisions to the proposed changes. The final version of the NEC is then published by the NFPA. The NEC is divided into chapters, articles, and sections. The chapters are the main divisions of the NEC. The articles are subdivisions of the chapters. The sections are subdivisions of the articles. The NEC also contains tables, figures, and examples. The tables provide information such as conductor ampacities, conduit fill, and grounding electrode sizes. The figures illustrate various electrical installations. The examples provide guidance on how to apply the NEC requirements. The NEC is a valuable resource for anyone who works with electricity. It provides the information needed to ensure electrical safety. In addition to the NEC, there are other resources available to help you learn about electrical safety. These resources include textbooks, training courses, and websites. If you are working with electricity, it is important to take the time to learn about electrical safety. This will help you protect yourself and others from electrical hazards.